everyone, welcome back to Chemical Engineering Statistics. So today we will look at one example of two levels full factorials experiments. So in this example, we have one problem. This is the problem that we face in the making of pulp and paper. So in the making of paper, we know or we suspect that the hardwood fiber concentration, the digester fat pressure, and the cooking time may affect the strength of the paper that we have. So for the investigation, we do experiments varying the value of the hardwood fiber concentration, digester fat pressure, and the cooking time. The experiment was conducted by full factorial design. In this case, we have three factors. Each factor is varied at 2 levels. So that means in this case, we have 2 to the power of 3 full factorial design experiments. The hardwood concentration is varied at 2% and 6%. The fat pressure is varied at 400 kPa and 650 kPa. The cooking hours is varied at 3 hours and 4 hours. Each experiment or each run was done in duplicate to completely or to measure the error of the experiment. All the experiment was conducted in random order. So here is the data of the paper strength that we got. This is the first this is the first replicate, and this is the second replicate. We can do ANOVA by using Minitab, and then we can have these results. The discussion on how to use Minitab to do the data analysis will be conducted during the class. So this is the results or the ANOVA table from Minitab from our data. It is important to know how to interpret the data obtained from this ANOVA table. So here we can see that we have linear model for pressure, for time, and for the hardwood concentration. Also, we have two-way interaction. Two-way interaction between concentration and pressure, concentration and time, and also pressure and time. And we also have three-way interaction between concentration, pressure, and time. Here we can also see the p-value of each effect. So first, let's have a look at the main effect. We have three main effects: concentration, pressure, and time. All of these main effects, p-values, are less than 0.05. Now, if we look at the two-way interaction, for the interaction of concentration and pressure, the p-value is less than 0.05, while for the two-way interaction for concentration time and pressure time, the p-value is more than 0.05. Similarly, for the three-way interaction concentration pressure time, the p-value is also more than 0.05. So those effects with p-value of more than 0.05, those effects are not significantly affected the model. Another way to evaluate the results can be conducted by looking at the Pareto chart. Here is the Pareto chart. Here we have all terms or all effects. Please note also that not all of the effects are significant. Those effects less than the red dotted line is not significant. So here we can see that AC, BC and ABC is not significant. Because we still have not significant effects, so we need to do a modular refinement. In model refinement, we analyze the data once more by using Minitab, but we exclude all those insignificant effects. So this is the results of the modular refinement. We can look at the ANOVA results for all effects, and also at the end we can build the regression equation of this particular case. So that's all for today. See you in the next video.